Unfortunately, our presentation from ISEG got canceled. So we have a quick fill-in on LoRa and amateur radio. But first, let's introduce people. So I'm going to start over in the corner, please.
V4RPP, Rob.
Chip, V4 Go Zulu. V4JUB, John.
V4UK, Dennis.
Wyatt, VE4WDZ.
Nicholas, VA4 NJF.
Scott, V4TQ.
Jamie, V4JST.
Steph, student, no call sign.
Okay, Derek, VE4HAY.
Andrew, V4KL.
I've got a variety of people online. I have no idea who the person. There's John H. There's some blurring at us. There's Brad C. Brian V4RBR. Mark MAB. Pat Martin. Scott VA4 SMC. Mike MPD. A couple of guys from Saskatchewan. I think that's VE5DWR.
Yeah.
I don't know. Resolution is not great on this thing. And VE5 SD. Thank you for the guys from Saskatchewan for coming in. Sorry, I said it's not here. But we have a filler program for you. And it's going to be interesting. This is something that people have been talking about a lot lately, and we're going to find out what it's all about. So Andrew, VE4KL, please.
Well, hello everybody.
Wait, let's.
So I'm Andrew, V4KL. I Googled all this last weekend. So I will talk as best I can about what LoRa is and how it can be used in amateur radio. So today, talk about what it is, ecosystems and terminologies. When you go to Google this, you know what to pay attention for. I'm going to briefly touch about Canadian regs for how LoRa works. We're going to talk a little bit about Meshtastic, MeshCore, LoRa APRS, and TinyGS, stands for Tiny Ground Station. It's kind of the four that are kind of popular right now when it comes to LoRa, especially in the amateur radio world. And then at the end, we're just going to play with some MeshCore and some other LoRa radios for fun. Okay, so the big question is, what is LoRa? So LoRa stands for long range. Basically, it's a proprietary chip made by a company called Semtech. Uses for low power communications. The modulation is called CHIRP spread spectrum. Sorry. There's a YouTube link. It's 3 minutes long, and it'll explain kind of what it is. But the short and sweet is it takes, instead of transmitting on the center frequency, it takes a bandwidth from that center frequency and starts at the bottom and works its way to the top, or starts at the top and works its way down. So on a waterfall, it looks like a ramp going up or a ramp going down. And by doing that, kind of spreading the energy over that width, it's able to decode really, really, really low faint signals. So what I've read so far is about 20 dB under the noise floor is what it's capable of decoding. Range advertised about 2 to 15 kilometers in an urban environment like Winnipeg, 20 kilometers rural, and you can do 100 kilometers line of sight. And this is all done at milliwatt levels. So we're talking 50, 100 milliwatts. It's able to do that. I believe on, it's either Meshtastic or MeshCore, like the record right now is like 300 something kilometers using literally milliwatts. Because it uses such low power, a device can run for a year or more on a battery without recharging. So you'll see a lot of devices, they'll add solar panels, but depending on how much it's transmitting, because of the way the LoRa protocol is built, it doesn't use a lot of energy, so it goes forever. It's pretty low data rate. We're talking about 300 bits per second to about 50 kilobits per second. That's all dependent on how much bandwidth you're using. And then another part of the protocol is how long that ramp takes to happen. So if you shorten the time, you can get more bits through, but you run into degradation in the range. Yeah, so we're not talking about voice or any kind of IP data going over top of this network. It's really short messages, telemetry type action. The When I talk about that chirp spread spectrum, it's very similar to how GPS works as well. So if you know much about GPS, that's how it works. Frequency ranges. So there's two that we're mostly operating in. So 33 centimeters, that's that 915 megahertz range. And then 70 centimeters is also where some LoRa activity is occurring. Some terminology. So you'll hear LoRa and you'll see a lot of stuff advertised with LoRaWAN. So LoRa is the actual physical layer. That's the protocol itself, the RF, using that chirp spread spectrum modulation. Like I said, is proprietary Semtech, but it's really at the hardware level. LoRaWAN is the networking protocol that Semtech made on top of LoRa. It's more just like a library of software that folks can use to deploy. So the commercial guys that are making like IoT sensors in the agricultural industry to do soil moisture sensors out in the fields, they're going to build their platform on LoRaWAN. Everything that we're going to talk about today has nothing to do with LoRaWAN. So whether a device is LoRaWAN compatible or not, doesn't matter. It's about whether it has the LoRa radio itself. Mentioned at the start, so the four big names that you'll see pop up in all your YouTube feeds are MeshCore, Meshtastic, APRS over LoRa, and TinyGS. So Meshtastic is kind of the original open source project for mesh networking. They call it the managed flooding approach, and we'll talk more about it later. But it's got a very large community, very popular with kind of the hikers and the preppers. Meshtastic's all in that unlicensed 915 megahertz spectrum. So lots of people that are not amateurs, that's what they're playing with. MeshCore there are some deficiencies to the flooding protocol that we'll talk about later. And MeshCore aims to improve on that. So it's much more closer to how amateurs think with regards to like repeaters and that kind of architecture. So that's kind of the one that's taken off, especially in the amateur community. APRS over LoRa, or LoRa APRS, that's another project where they took LoRa radios and you take an APRS packet and you just send it over LoRa instead of the traditional VHF using AFSK, right? So it's much closer to, or sorry, I should say, it's happening in the 70 centimeter band primarily. And then TinyGS is basically LoRa transponders on kind of mini-sats or CubeSats that are up there. And so people are deploying ground stations to receive that telemetry, feed it all to a server, and then the operators of the satellites have a way to get telemetry back to them. We'll get back to those in a minute. I'll just cover the regulations real quickly. So I mentioned the unlicensed versus the licensed. So both of these, or I should say, the unlicensed side of the house happens in the 33 centimeter. It's overlap. It's the same band at 902 to 928 area. However, it's where the device, it's how the device is operated determines what side of this chart you're going to be on. So if you're operating it as an unlicensed device, it's under the ISM, the Instrumentation Scientific Medical regulations, ISED RSS 247. If you want to get deep into the regs, I'm sure our ISED presenter can talk all about that. But really what it comes down to is the power limit. From what I could find is up to 1 watt transmitter power. It is lower priority than amateur. It's like right down at the bottom in terms of what they get in permission to use. So it has to be able to accept interference, must not cause interference. And it has to be certified license exempt equipment. So typically when you look at a lot of those devices that are unlicensed at home, that you have around your house, could be like weather stations or things like that, they'll have an IC number. I'm going to note that most of these devices have FCC certifications, but don't have IC numbers associated with them. kind of, so technically operating them in Canada is a bit of a gray area.
Just like most of the Baofangs.
Yeah, like most of the Baofangs. On this opinion side of things, disclaimer, I'm not a lawyer. What I say about regulations, it's on you on how you operate this stuff. But basically, in the unlicensed, technically a lot of them don't have an IC number. They probably should. But as long as we're not causing interference, it doesn't seem like I said is really on anybody's butt about it. The LoRa chip, being a proprietary chip, is only made by one company. So all these chips are made for the unlicensed world, right? So most of these chips that we're getting, these off-the-shelf modules, they're in that low milliwatt power range. On the license side, RBR4 and the other regulations higher than that, right? That we all know about. Power limit, you could go as high as you're qualified to, depending if you're basic or advanced. So if you want to make a 250 watt LoRa radio, theoretically we could slap a power amplifier on it, so long as we follow our standard stuff of using the minimum necessary, don't cause interference, all that kind of stuff. Because even though we rank slightly higher than unlicensed, we're still secondary users on that 33 centimeter band. Obviously we need our amateur radio. We have to follow the station identification processes and things like that. But the benefits, right, is that higher power that we're allowed. The other thing that people are doing, like the ones that are playing with it, LoRa APRS, is that we can now go in the 70 centimeter band. So unlicensed is only 33. But if we're transmitting in the 70, we're doing it under our amateur license, not under the unlicensed exemption. So to sum it up, there's unlicensed in 33, and then you can do licensed in 33 and 70. Follow the rules that are needed in whatever place that you're operating and how you're operating it.
So question about the 70 centimeter chips. Those are technically being, or on paper, those are being produced for like the 433 meg unlicensed band, aren't they? So are they just not limited enough to where amateurs can make extra use of them, or?
So they're basically, it's because Semtech is making chips for the European market.
Okay.
And so they physically made, so that's where the 70 centimeter is, because the unlicensed in Europe is different. They don't have the 900 megahertz. So their unlicensed is in the 70 centimeter. So we're just importing them. And I believe some of the chips are dual. They can do the 70 and the 33. But that's where it's coming from. Encryption, again, not a lawyer. Do what you please with your operations. I'm not responsible for how you're operating it. Unlicensed, they can do encrypted. Because like I was saying here, radio communication regulations, right? The section 47B doesn't apply to that unlicensed area. So Meshtastic, MeshCore are both encrypted by default. Typically using AES 256 or some other protocol. And Meshtastic can be disabled. MeshCore can't right now. So it is what it is. If you're operating in your amateur license, right? So you're either running higher power or you're running non-certified equipment, or you're down in the 70 centimeter band, can't go encrypted. That's what that means. There is some information about encryption on RAC's website. They do a public key registry. So technically, if you take your private key, post it to the website, you might get around the regulations. I'm not a lawyer. How you want to deal with encryption is up to you. Any questions so far? Okay, so Meshtastic, open source systems, all the code's on GitHub, basically. Short text messages and telemetry, designed for off-grid using an expensive commercially available LoRa hardware. Yeah, this hardware is cheap. If you're paying the Amazon tax, it's about $50 to get started. If you want to go through AliExpress, you're talking $12 to get a lot of this equipment. Meshtastic has, you'll interact with it. It'll be a device that looks like one of these. right? That's how you interact with it. That connects to my phone. There's other ones that look like old school Blackberries where the interface to send your text message is all built in with the radio. Primarily in the license exempt band and encryption by default. Okay, so what the architecture looks like. So it creates a mesh, everything talks to each other. There's no central controller, there's no fixed routing tables. Every radio will hear the traffic and can help pass it along. So when you send a message from your phone, right, it goes either via Bluetooth, Wi-Fi, some can be USB, gets to the radio. Once it gets to the radio, now you're going to go over the LoRa RF, and it goes out to every radio. Every radio will then rebroadcast that message, so long as there's a hop limit. So if you know, like IP, time to live counters kind of thing, so you'll program it into your message how many hops you want it to max out at. If you set 4 hops, every time a radio transmits it, it'll decrement it by 1 to the point that it hits 0, and then the message will stop being retransmitted. They call it, so that's the typical flooding protocol, but the Meshtastic, to kind of keep the transmissions down, to bring them down a little bit, it'll do 2 things when it receives a message. The first thing it does is it looks and sees if it has already seen that message. Meshtastic keeps a record of about 40 messages, and if it's already transmitted it, it won't transmit it a second time. The other thing it'll do is it'll delay before it sends it out to see if anybody else will send it out. So if it sees it being sent by somebody else or repeated by somebody else, it'll just hold back and not send again. So with Meshtastic 2, all the radios run the same software, so they all kind of repeat the same. There's not really a repeaters or radios that are separate. Everything's just repeating each other. The direct messages, it can remember who is nearby and send a direct message with essentially a 0 hop, so that it doesn't get retransmitted. But I mean, everybody else can still see. The big thing with getting all these radios to talk together is 3 components that need to be set in your configuration for everything to work. So I talked earlier about frequency, the bandwidth, and then the spread factor, which is that time for the ramp. So if any of those are not set correctly, if your bandwidth is different than the person you're trying to talk to, they will not communicate to each other. They won't know how to decode the modulation out of the mess. And then messages as well, we'll see in the app later, but they get grouped up into channels. So part of the protocol of Meshtastic itself is addressing messages either to a person or to a kind of a talk group, if you would, so a channel. That all plays in with the encryption, the public keys play into that addressing. So equipment, I just threw up a couple. So you have like the Heltec V3, it's just you buy it as a board. A lot of people 3D print a case for it. You can buy cases as well. We got the BlackBerry looking thing, and then some people deploy them just on hilltops or what have you. It's important to note that what's on the left and what's on the right is the exact same thing. In terms of its software and how it's operating, they're identical. Strengths of Meshtastic is that low barrier to enter, works on very low bandwidth, robust, really strong ecosystem, lots of community, lots of users. Really popular. I mentioned here with like search and rescue or hikers, things like that. So think about groups of like less than 20 people operating away from other groups is where this really works well. Because that flooding, when you start getting too many users and too many hops, or the hops start getting really tight together, the whole network kind of collapses. So once you get over, I think it's like 30 or 40 people, Meshtastic just starts to collapse, unless you can reduce that flooding. Like I said, it doesn't scale well. There's no routing control. You just blast out your message. The traffic model is broadcast centric. It is nicer in terms of the regulatory compliance because it is able to disable its encryption. But other than that, it's got some issues. So because of that, we got MeshCore, and so C++ library, multi-hop packet routing, kind of the similar things, but the real feature here is the hybrid routing. So it actually learns where the packets flow the quickest, which helps reduce how many radios are retransmitting everything. It's role-based, so there's actually 3 firmwares that exist. You have your companion nodes, your repeater nodes, and your server nodes, your room nodes. Talk about those in a second. Obviously, same low overhead, but really the background traffic and that airtime usage starts dropping because not everybody is repeating. You can configure it, right? So you can set maximum hop counts, access control, zoning. It does have a store and forward support. So it does have essentially a BBS, right? So you post your message to the board, and then if somebody else comes into range, they're able to download from that board. So you don't necessarily have to be there at the same time. So I mentioned the 3 firmware. So companion nodes, that's what this one is flashed with, and it's the one that you use to interact. So a companion node is the only one that can send and receive messages. However, a companion node doesn't retransmit any messages. It's not a repeater, unlike Meshtastic, where everybody's a repeater. The repeater nodes are specifically configured to do that. And what that does is, let's say we have 20 people all closely together. Instead of me sending out a message and all 20 of these radios start going off at once, you send out the message, the repeater will send it out once, and all 20 people will get it. So obviously, like, instead of 20 transmitters, I got 2 transmits. We're really reducing that airtime. The other advantage in terms of power consumption is that when you have Meshtastic, I send out a message and then all 20 radios go off. All 20 of us in the room have all consumed battery power. Whereas if I have my repeater with my solar panel on the roof, I transmit my message, the repeater used that power to repeat it, but all of you didn't use any power because you never transmitted, you just received, right? So it's much more energy efficient. The room server nodes are basically nodes that have the ability to save a message and wait for the person that it's addressed to come to range and be able to download it. So a lot of repeaters, you can, I believe, activate the room server on a repeater, so it can do dual action there. But the companion nodes are very separate from the repeaters. Makes sense? So just for comparison, right? What do I have here? So MeshCore is on the left here, Meshtastic's on the right, should have titled that. But really, the routing approach, having the repeaters be the only ones that forward the packets, makes for a lot less network overhead, a lot quieter airtime, which also helps with your hop limit. So MeshCore can do up to 64 hops, theoretically, in the software. Whereas Meshtastic defaults to 3, but it can't support more than 7. After 7, the whole thing falls apart. Target audience, MeshCore is more oriented to the amateur radio world and some of the principles of not wasting airtime, whereas Meshtastic kind of goes on the blast it out to everybody in kind of the GRMRS, FRS world of radio versus the structured professional amateur radio side of the world. Yeah, larger networks, and MeshCore is much newer. It's growing out of the UK, but it's getting very popular and more development is happening. The hardware, it's exactly the same. So what's the difference between Meshtastic and MeshCore is all software based. The hardware is the same for both softwares. So if you want to get started with MeshCore, we're not going to do this, but essentially you get yourself some hardware off AliExpress or Amazon. You flash the firmware. Both Meshtastic and MeshCore have like web flashers. So you literally just go to a website, plug in your device, it'll detect the USB, hit your permissions on your browser, and you can load the software onto the device. It's important to choose your role when you're going to flash the software. In MeshCore, you can just select it. Make sure that if you're operating as an amateur that you set your settings that are compatible with our licensing requirements. And install a client app. So the client app is just the app that's going to be on your phone or your computer that's able to talk to your physical device. So like I have MeshCore installed on my phone and it Bluetooth connects to my device.
Question.
Yes.
So a few slides have already said MeshCore and it says disable the encryption. So can you disable the MeshCore? Because earlier you said no.
You can.
Okay, but the slide says disable encryption. And so did two other slides.
I gotta correct my slides.
Okay.
But as far as I can tell, there's no way right now to fully disable it. Even downloading the key is a bit of a pain in the butt. So. But I did not tell you to not disable your encryption. And then, so like I said, join the network. So connect to your device and then send out an advertisement, which is your radio saying, hello, it's me, to everybody, and then see if people want to text you. That's pretty much how it works. Got some links. I'll make sure it's all posted up on the website after, if anybody wants to go to them. LoRa APRS. There's not a ton of logos or anything. Basically, it's a software. There was, yeah, that's the correct one. So there was an original project. That project was deprecated in September. So this Ricardo Guzman, he's kind of taken on the project. So that's kind of where the most up-to-date firmware is today. There is two firmwares that exist. So there's the APRS Tracker. So that would be the firmware that you would download, install on a device, and send out APRS packets over LoRa in your car. And then there's an iGate as well that somebody could set up at home, receive those LoRa APRS packets over LoRa, and transmit them to APRS IS, which is the internet, core of APRS. So it's important to note that LoRa APRS will not talk to traditional APRS on the VHF, right? Because this stuff operates, most of it is all operating in the 70 centimeter band, right? So it's kind of APRS over UHF, but instead of using the audio frequency shift keying that APRS uses, it uses LoRa to modulate. So therefore you need separate iGates to be able to receive it. However, once it hits the internet, it turns it to IP, and both of them will show up on, if you go to aprs.fi, you can see both. Whether the iGate will take a VHF message from the internet system and transmit it out onto LoRa, that has to do with how the iGate is configured. Most will not. I don't know all the details about it, but basically treat APRS LoRa and APRS VHF as kind of two separate systems that amalgamate on the internet. Yeah, you can also configure a node as a digipeater as well, and lots of people also configure their iGate to be a digipeater. But those concepts of how APRS work are very similar, just a different modulation. The equipment, exactly the same equipment as MeshCore and Meshtastic, right? So I can't remember what the manufacturer is called, but basically the T-beam on the left, and then some other device there on the right. Most of these, I'll point out here, so the on the right-hand side, this white chip, that's, if I'm not mistaken, that is your actual LoRa RF chip.
That's the GPS chip.
That's a GPS chip? Okay. So LoRa chip is probably on the back or something.
I think it's the middle, probably the middle one.
Is the middle one? Or is that?
It might be on the back.
I thought it has Wi-Fi. I think that's the ESP32. That being said, the boards have multiple chips. Most of them have ESP32 microcontrollers. So think kind of like an Arduino type microcontroller, so very, very low power computer. That's what's talking to the LoRa chip. That T-beam, it's got a GPS chip as well. So if you do an APRS tracking, you actually have GPS. If you have one of these Heltec like V3s, there's no GPS chip on it. So different advantages to either one, but those ESP32s super low power as well, so the whole package doesn't really consume much. Yeah. Any questions on kind of LoRa APRS?
So the actual ESP chip or whatever CPU it has, it still knows enough that it knows what frequency it's on. Like it has to talk to the radio chipset enough for that detail?
Yes.
Or is it completely unaware of what frequency it's operating on?
No, I'm pretty sure it knows because it you can change it.
Okay.
Yeah, the chip isn't like locked to a center frequency.
So then whatever firmware you're like, if APRS is primarily designed around 400 or 70 centimeter, the firmware would have to support both bands if you wanted to put that firmware onto a 900 megahertz LoRa device.
I believe so. Yeah.
Okay.
Yeah. I didn't do a ton of research to see how his software is working. I know that a lot of people are doing it on 70 centimeters, whether it could be done on 33. I want to say it can be, but the other thing with a lot of these MeshCore, Meshtastic things is like the settings, for example, for Meshtastic or MeshCore, you kind of have to know the local community to get the secret password, if you would. Because if you, like I said, it's frequency, bandwidth, and that ramp speed, right? The sweep. If any of those three settings are different than your friend, you're not gonna communicate, right? So it's kind of like what has market penetration to be able to actually work. Because if I'm the only one rolling around with 900 megahertz APRS and there's no iGates, then it's not super useful. But that's what I've got so far. Okay, and then TinyGS, I mention it because there's a few amateurs in the area that are running them. There's one in here Steinbach, and then there's at least one here in Winnipeg. But basically, they throw up a antenna on the roof, hook up the same equipment as anything else, flash it with the TinyGS firmware. They're able to receive the LoRa coming down from the satellites. This all feeds into via MQTT. Basically, it's a messaging protocol that's very efficient to some servers. It's run by some Germans. And then they take all that information, aggregate it. They provide an API to satellite operators so they can get the information. And then they also have like a Telegram bot and stuff like that. So every time their satellite is seen and sending out their health checks, you know, the operator of the satellite can see that their satellite is still alive. Yeah. Any questions on that?
Brad has his hand up. I don't know how long it's been up on Zoom.
Brad, go ahead.
Yeah, I've got a question. It seems like MeshCore and Meshtastic are two independent systems, but are they actually compatible with each other?
They're not compatible. They're completely isolated.
Okay, thank you.
Yep. All right. Cool. So now would be pretty much the live MeshCore demo. I don't really have anything else for presentations, but Nicholas, I believe you brought, is that a repeater or?
That's a repeater.
There's a repeater there. And then we can show as well.
So is there a desktop app as well, or is it if you don't have one with the keyboard, is it always using your phone to interface with it?
For MeshCore,
Yeah, for either.
for MeshCore, I know there is a web client that can do like Bluetooth to the device. And I believe it can do USB direct as well. But yeah, they're very much like a cell phone Bluetooth
Yeah.
kind of mentality. So those are all like, just to give an example, the labels that you see, the gray labels, those are all satellites that would be received, and then all the green satellite dishes, ground station dishes, that's all the receivers. Obviously very popular in Europe. Canada, we don't have a ton, but oh, there's Zoom sets. Okay. You can see there's 2 here in Winnipeg. I'll just so our friend V4 DRK. And you can see, I believe the load. So that's all the packets they've received in the last 30 days. Each color is a different satellite that they received packets for. You see the 10 minutes ago, there's Tianqi 32 satellite went overhead. So it's kind of cool if you want to get into contributing. The distances on it are pretty wild. There's 2,600 kilometers there. Obviously, line of sight when you're looking straight up at space. But that's it for that. And then, like I want to show you, APRS 5. I was in Wichita. And DRK again, because I know he's there. You'll notice here that it's over LoRa. So, like I said, it shows up on APRS 5. And
Which you scroll down, which stations has he heard? Just himself.
yeah. So not a ton of people using it, but cool technology. And I think the big thing with this is like cost, right? Like you could make an APRS tracker on the roof of your car for like 50 to 100 bucks versus buying a $300 VHF radio and everything else has to go with it. Or
well, if it's achieving like 10-kilometer range at milliwatts rather than watts, like
yeah,
a 5-watt APRS beacon is lucky to get 10 kilometers line of sight. You're probably only getting 5
right,
without hitting the digipeater.
So it's the ability to decode into the noise is
Theoretically better than
just pushing more power.
Traditional APRS. So
yeah.
If you had, in theory, in Winnipeg, if you only had like 1 or 2 iGates,
yeah,
in a good spot, you could probably cover the city, even just using tiny little tracker beacons.
Yeah,
on vehicles. So
like this would be really fun to like throw an iGate up on a roof somewhere and then just drive around with a tracker and see what kind of range you get.
2 messages.
Okay, so the question on TinyGS, so it's receive only. It does not have the ability to send command and control signals up to the satellite. So yeah, so my understanding is they typically use it to get kind of 24-hour coverage for receive and health, but they still have to rely on a traditional ground station to actually send it command and control. Cool. I will end the sharing now. We can throw the lights back on and play because I don't have a way to project the client up on the screen. But how much it's going to be useful for the Zoom people, but I'll just show like on the app here at contacts.
Video going. Why isn't our video up here?
Oh, it's just they have the self view turned off. It's there. Okay, so basically when I arrived, I only had one contact. My contacts auto add based on who is in range and advertising. So S9, I believe, is your transmitter, and then I have the repeaters as well. And a 2.0, sending out a flood message. As an example, Nicholas just sent out a flood. I receive it here, and it's a direct message. Channels are public, so if we sent that out on public, it would go to anybody that has a MeshCore within range right now, which is going to be pretty limited to essentially this room. Then the map function will show you where people are, but only if they've attached the telemetry, the actual lat long to their message. So like mine is set up where I don't have a GPS attached, so it just sends out a default location. Some people set it to 00, so that way it's not giving away, you know, their home address or things like that. One thing I'd like to keep in mind is that because it's unlicensed, like any teenager can have one. So how you want to deal with your privacy, just remember that it's not like restricted to amateurs or anything like that.
So the app isn't able to grab from the phone's GPS and attach it to the message?
You can set the GPS in the app with your phone's GPS, but it won't attach it to the messages.
Automatic.
It won't like live update.
So what's the point of doing it?
Anyway, they just built that into the app.
Yeah. To be fair, a lot of this is very much in like the 1.0.
Well, if you wanna get around Google,
Was that?
if you'd wanna get around Google,
Yeah.
Yeah, except you're carrying your Google phone with you.
you don't use the GPS from Google.
Yeah. So that's what's kind of neat with this is like it doesn't use any cloud servers or anything like that. It's just all point to point or you know, I talked with a couple people earlier about like what's going on in Minnesota, and like a lot of people are using that to communicate because makes it really hard for like 3-letter agencies to download everything if it never actually runs to their equipment, right? Yeah. So anything anybody wants to see or try with it?
Okay, so I've got a whole bunch of questions.
Cool, let's go.
So MeshCore is more designed around amateur radio usage. However, there's the encryption issue, but
Yes.
let's ignore that for now. What are the practical applications that amateurs here, let's say in Winnipeg, could use? Could we put up a repeater somewhere, throw a bunch of little guys like that in marathon vehicles and cover the marathon?
Yep. So that's one thing you could do is basically a way to text message without using a cell network. That's an option. When we talk about marathon and tracking, like depending on the performance of the APRS stuff, that could be super interesting to see how it behaves. The thing too with an iGate is it just needs internet connection as well. So you could do like trackers on every vehicle, and because it's so inexpensive, if they're like Wi-Fi hotspotted to a few of the what do they call it, the stations there throughout the track, strategically located, as the vehicle goes by, it's going to hit that iGate, and even if we don't have iGates up high.
But if we had a repeater up high, for instance, like across the river on Osborne Street, which is sort of central to the marathon, I suppose.
Yeah.
That would cover all of it, especially if it's got a 10-kilometer range.
Potentially. We'd have to for sure like go drive the route
Yeah.
and just see what kind of performance we're getting. But theoretically, yeah, it would be as performant, if not more performant. And the other advantage I was saying with power, like a lot of these devices, if I put a battery on this, it would go for days. Right. So in terms of marathon type applications, a box like that could just have a radio. You don't have a 12-volt plug, nothing. Just stick the magnet on the roof and call it a day.
So if you took your little thing here and threw it on the dash of a vehicle,
yeah,
where it gets the window, can see the GPS easily.
If I had GPS on there, yeah.
Yeah. Okay.
Yeah.
So go on APRS.5 and just pull up Dan's trace track history. I'm just curious if he's been running it far out. I don't know. I think it was D4DRK.
Well, he just knows Dan's number by heart.
It was on the screen 10 minutes ago. Yeah, so set the track show last to be 1 week or 7 days, and the track tail length to be.
There you go. So basically the dog walk.
I think he's gone further than that.
Yeah.
Well, he had it here a couple weeks ago.
Yeah, I think he said he was getting it from here.
2 Tango Quebec.
That,
5, Dutch 5.
oh, you're right here. Within the last hour.
Your house is moving. Mobile house is
Wish I did.
I think you need to put the track tail link there.
Oh,
and
yeah,
also
yeah.
7 days.
There you go.
Yeah. So now check Dan again. See if he shows any more. There we go. So yeah, he's had some check-ins from St. James.
It's been all over the place.
And that's all being picked up by his home antenna.
Yeah, which is like at 20 feet maybe.
Yeah, that's
Yeah.
not very high.
Yeah, so the fact that it came out from all the way.
It shows me
Yeah.
where it was last time.
Well, and there's confirmation too that it went through -10, right? So
Yeah.
it's not a secret one that we don't know about.
Okay,
So yeah, so there's some neat applications of it.
Okay, so there's some other questions now, so. For amateur radio use.
Yeah.
If we're in the 900 meg band, we can't restrict it necessarily to non-amateurs, or can we?
MeshCore we can't.
Can?
No, can't.
Can't. Okay, but we don't have to tell them our, well, frequency, they may be fine, but then they gotta figure out. The bandwidth and that slope,
Well, it's all preset settings.
but we can change it.
We could, like, it's one of those things, like you would be blocking the repeating of it, but in terms of like message security. Like if I send a message to Nicholas, it's encrypted with his public key. So he's the only one, even though Steph is repeating it, only Nicholas can read that message. And you can do the same thing with the channels. So the channels can have a public key associated with them as well.
I'm just trying to figure out how to stop non-amateurs from going across an amateur radio.
I don't think that's built into the
Yeah.
firmware.
Like in terms of like, if we were running our repeaters under our amateur licensing, so we had our repeaters boosted or something like that.
Yeah.
I don't believe, we'd have to check. MeshCore might have access control list ability, but I don't know where that's sitting in its development. So the safest way to do it, if the club wanted to do it, is to keep it all in the unlicensed world. And then we don't run into any regulatory issues.
I don't think the creators of the 2 firmwares were designing it to be only used by one group.
Yeah.
The repeaters will repeat it.
APRS LoRa though, that one has like, you actually program in your frequency and things like that, so there is some. And you're operating the 7mm anyway, so there shouldn't be any amateurs on it, regardless, or non-amateurs on it. Yeah.
And we could, in theory, run MeshCore on 70 centimeters if we wanted to.
Like physically, I would say yes, whether the software can actually do it, not 100%
Well,
sure on that.
yeah, because it's all the same firmware for the whole world.
Yeah.
It's all built in.
Oh yeah, so you could probably just change your country to Europe.
Yeah.
And it would unlock it, kind of like what we do with like compliance tests on the Wi-Fi stuff. You could jerry rig it, and again, we're taking that risk that now we're operating it under our amateur license.
The hardware won't move out of the band, but the software does.
Yeah. So if you bought a European chip. Yeah. Okay. Any other questions?
So what's the cheapest way to get a repeater going? Is it with the Heltec ones or the?
The Heltecs are pretty much the cheapest ones out there.
I think because
You probably spend more on the enclosure and an outdoor antenna.
And does that come with a
Yeah.
battery too, or no?
No.
No,
No, $30 will buy you a raw PCB with an antenna and a 2-inch cable off of Amazon. Yeah.
$30 gets you a V4 on AliExpress, and they're way more stable.
So that's basically what I ordered. That's inside of that case right there. So it comes with, this one's nice because the header pins are not soldered on. Because I didn't need them, but that's pretty much it. I did use it comes with a power cable, so if you want to solder it onto a battery or something, but I didn't use it. I just power it off of the USB plugged in. And then the case is just 3D printed. That just snaps 2 pieces together to protect the board. The board only has 2 buttons on it. So this bottom button's the reset button. So if I press that, the whole board resets. And then if I press this one, it just cycles through some different pages. But super, super basic. The other ones that are popular right now, kind of what called the T-beams. Like you can order these ones direct from the company for $30. I don't know what shipping would cost on something like that, but you'll notice that you can buy them the 433 or the 915. So depending on what you need, you can get them. These T-beams are kind of cool because they put a battery compartment on the back. So it takes a 18650 lithium battery, all built in, and it has the GPS for basically the same price technically. Might be USD, but be pretty close.
So this is the one that Dan was showing off running LoRa APRS.
Yeah.
So, yeah, that one there.
Yeah.
So if that lithium battery lasts even just a couple days, like you throw that on the dashboard of a car.
Yeah.
You go drive around with it. If it can make it 5 to 10K, then you only need a couple of years to cover the city.
And with that 1 watt limit too is EIRP, so it's the effective radiated power. So you have to technically consider your antenna in that under the unlicensed thing. However, if you're an amateur, right, and you want to throw an antenna that, I don't know, 8x is the power and goes above that 1 watt effective, like theoretically you could, you're just falling into your amateur privileges versus your unlicensed world.
Well, and APRS is built for everything to be call signed anyway, so.
Yeah, so APRS, like LoRa APRS would be like pretty regulatory compliant.
Yeah.
Until there's some interference or something and I said actually cares.
The software, is it open source?
Oh, yeah.
So why haven't amateurs gotten into it to figure out how to turn off encryption if it's open source?
Like the MeshCore stuff?
Yeah.
So the pull request.
Yeah.
That's really what it comes down to, right? I don't know how many developers are working on it or I think the big thing is the motivation, right? What's on their list for development. And I think there's a lot of other things that are higher than encryption disabling because most of the users are doing it in the unlicensed anyways. So having that feature is just low in their roadmap. Yeah.
That's not counting shipping though with that.
Probably not.
No,
It's
because
probably
I
US.
actually sourced them both out from here and from Alley.
Yeah.
And they both balance out the same by the time they do the shipping on this.
Yeah, that's the one thing I found with ordering stuff from China is it's definitely like item plus shipping in terms of how you view things because it's not Amazon Prime with free shipping on everything. And Chinese shipping right now is about 3 weeks to get anything. And right now probably 4 to 5 because it's Chinese New Year, so everybody's shut down. I've been waiting on that.
Doesn't AliExpress have a
Yeah.
sale? Like it's not Prime Day, but they call it 222 day or something, or
AliExpress is
every-
always flashing something. Ali is a wild, it's a wild marketplace.
They turned into Temu real quick.
Yeah. But it's it'll take a while to get stuff, but man, it's cheaper than Amazon. Yeah. But that's basically where you get the gear, and then once you get on, there's also a lot of like there are some Facebook groups and Telegram channels. It's kind of, again, it's very new, very early access, very, very sketch, to be quite honest. Those Telegram groups are where you get the settings or things like that, or because we're part of a ham club, you can just show up or message within the group on the repeater, and somebody probably has the settings. Because right now for MeshCore, it's 910.525 with a 62.5 bandwidth and a spreading factor of 7 is what I just found it on the MeshCore map. Somebody else had that setting, so I just matched it and it worked.
That's the presets.
Yeah, it's the recommendation from MeshCore on their website. But it's yeah, it's cool tech. I like it because it's low power and for what it can do, and it's cheap, it's small. Instead of lugging around a massive radio and big coax out to an antenna that I have bolted to my fender. It's kind of neat stuff. You talked about too, like how people could use it, like the ability for telemetry, I think is pretty interesting. So you can have devices heartbeat via an API over the mesh. So that's how it's being used, like mostly commercially. It's big in like the agricultural industry because if you're running a 5,000 acre farm, instead of running Wi-Fi to all corners of your fields to be able to get your weather data and stuff, everything just feeds through the mesh back to a gateway, and you can see, every 1,000 feet down your field what your soil moisture is. And because the LoRa, like the actual LoRa chip, like my assumption is if they're selling these things for $33, the chip is not more than $1, right, of what they're actually paying. So in terms of deploying these sensors, they could build an entire environmental sensor with temperature and humidity and stuff for well under $100 an item.
But if it comes in a green and yellow John Deere box, it's $4,000.
Oh, 100%. Yeah. Yeah. You need the subscription for your for your tractor. That's also part of the whole like the mesh world, right? Is there's no subscription or anything like that. It's just everybody helping each other. That's part of the whole like repeating as well, right? It's you're helping other people get their messages across as well. It's with the consolidation of the telecom industry in Canada right now, it's pretty rough. Cool.
Any questions?
I was gonna ask about this device, which antenna that is, what's in that one?
That's the Alpha 915 antenna. And it has the rack 4631 board in it with it's the expandable board, but it doesn't have any expansion modules.
Oh yeah, what's it called? The rack WizBlock? Yeah,
WizBlock
Yeah, so there's
4631.
it's a cool one because it's like, yeah, it's like modular, right?
Yeah, you can add modules as you want. Different GPS or environmental sensors. You can add LTE module for it to go through for your internet connection to be cellular, or you can add a PoE module to it, so it'll go through internet and can get power over internet, Ethernet.
Yeah, so theoretically, like you could probably assemble something where it does like MeshCore and not to say MeshCore, but like APRS directly to an LTE modem, and then it can be its own iGate that's also wireless out into
Because the rack stuff comes in just about every band.
Yeah. So whether the software exists for that, that's you know, play around in GitHub, but yeah,
If the MeshCore can receive the LoRa APRS,
separate systems,
separate systems.
Yeah.
It's the same hardware though.
same hardware.
Okay, so the
Same hardware, same modulation, different
Different
messaging.
different messaging. Okay, so you're sending just a different message into it.
Yeah.
So if you have LoRa APRS and you can put it into an iGate, so it must be able to talk to the internet. Why can't the MeshCore talk to the internet?
Nobody wrote the software.
Nobody wrote the software.
So like Meshtastic has like a module, a plugin to go from Meshtastic and then transmit those Meshtastic messages over MQTT, which is the protocol, and then like fire that over the internet. But that's just because somebody wrote the software.
Somebody wrote the software.
So that's
It's just too new.
it's new, and then it's getting the right people interested in it, right?
I don't think the makers, because the makers of MeshCore made it because they didn't like Meshtastic. MeshCore came after Meshtastic.
Yeah.
And I think a big thing of MeshCore was they didn't need the internet.
Yeah. So in terms of feature sets, it's just low in the. Like if they ever get to version 5 and there's 300 developers working on it, like, well, if somebody wants to contribute it, I'm sure they probably wouldn't necessarily say no, but in terms of where their efforts are going, it's not necessarily there. Because like you said, there needs to be a need for it. You can do 64 hops on MeshCore, which for like the city the size of Winnipeg, we can get a lot of stations on the air before we start running into any kind of issues.
Especially if you can get them up high.
Yeah. But with Meshtastic, right? Like there is that managed flooding thing. So if 20 of us are in a room and I fire out, they will sort of negotiate among themselves to not all 20 rebroadcast, because that would just be straight flooding. So there is a little bit of like, it waits to see if somebody else repeats it and they'll stay silent, but it's not perfect. And so like once you hit 5 hops, like you're not going to have 1,000 node Meshtastic network actually function and have the messages. The other thing is too is reliability. You might get some messages, you might not get all of them. Whereas MeshCore with 1,000 people or even like say 200 people, it'll stay reliable.
And you can define the routing in MeshCore?
Yes.
Yeah.
You can actually lock it down that it will only go the direction you say it will go.
I don't have a ton of experience, just I read that it can be done.
Yeah, I read it too, but.
The other thing is too is like it part of getting other people on it, and if we can get a repeater on a roof is it's hard to experiment when I'm sitting at home and it's like I hit refresh and there's nobody else around. So like I'm sure we could play around with the routing, but like if I have nowhere to route to or between, makes it tougher. That being said, these things are $30, so I could probably buy a dozen and just throw them in people's flower beds.
Yeah.
Then I know exactly what everybody's flower bed moisture levels are.
So does it auto sleep? Like if you have it running on a battery, how often is it like listening to the band versus sleeping?
Very good question.
It doesn't go to sleep. It's just really, really efficient.
Yeah.
How long does the battery last?
Well, it really depends. The Heltech stuff, you get about 12 hours, maybe. But the rack stuff, I have an MQTT gateway somewhere down the street from me, and that thing's always going off. And the repeater in the backyard can last a week and a half with the solar panel on.
A week and a half, and then what? You have to,
Recharge the battery.
solar panel will do it?
Well, the solar panel was broken when I tested that.
So with a functional solar panel.
It should continue working all the time.
But even like I showed that picture on the mountain, like there's nodes out there that are like out in the woods, and they're anecdotally I've seen on like YouTube and stuff, guys that have said like they've had a node up on a hill for like 3 years. They've never touched it, never maintained it, and it's still repeating.
So in theory, if Ram were to put up a MeshCore repeater on top of beside one of our repeaters, with a little solar panel, you just run and be there.
Literally, you take that right there,
Yeah.
you zip tie it to the pole,
Yeah.
and then we never talk about it. Well, we talk about it, but we just,
Yeah.
we never,
It's just there and it just does its thing.
it's just there, yeah. I
Or
don't
we
like-
take a couple extra minutes and run a power cable to it.
Yeah.
Since we have beautiful AC power in all of our cities.
Yeah,
You can buy 30-foot USB-C cables on Amazon
yeah.
and they do work.
We'll probably pay more for the power cable than the but
Could you do PoE over?
probably theoretically, yeah.
They sell them. I got one of them shipping to me.
Yeah.
Try out.
I even like, I would assume too that, I don't know if you ever seen like that PoE
Separator.
separators, and basically you plug PoE in it and it just gives you a LAN and a USB-C or a micro USB.
Okay.
You just don't use the LAN.
Yeah.
Yeah. Because like I said, these things will just act, essentially think of it like a digipeater, right? It just sits up there and does its thing. If we were playing in the Meshtastic world, maybe we'd connect it to IP so we could do MQTT. Personally, I'm not super interested in Meshtastic, but
No.
MeshCore repeater on a roof would probably be pretty good. It's all about experimentation, right? It's about seeing what we can do and how far we can go, right? It's kind of like, I compare it to the QRP, like POTA activators. It's like, how far can they go on 1 watt of CW?
See if there's any questions. Anybody on Zoom have a question? What are those?
Old ones.
Okay.
So, yeah, I'd be curious how far we could get, especially if we have rooftop repeaters. Like at that point, especially in the prairies, we're just reliant on line of sight and the curvature of the earth to decide how far we can go.
Especially, I'd be curious at a site like, well, we'd have to really get back to here, but if you had one, say, on the roof of Gimli. And you
Yeah.
had boats out on the lake. How much coverage of the lake can you get from one station on the roof of the distillery?
Yeah. How high is the distillery? Do we know?
100 feet,
100 feet?
maybe?
Theoretical line of sight.
Gemini question.
Yeah.
On the open plain across the lake, 100 feet.
Horizon visibility 100 feet should be, well, because we're talking about boats, 11.7 nautical miles or 21 and a bit kilometers. So is that the width? No, it's way wider than 20.
Probably about
I
half.
mean, you can see across the Victoria Beach from Gimli. You can see the land on the other side, so
Yeah.
you should be able to talk to it anywhere on the lake there.
Yeah, that's like the other thing too. If you're into maritime tracking, if you know about AIS, that's all just VHF radio. Similar, it's basically APRS, but for the maritime world, it's like it's expensive because you have to buy like a maritime radio with it built in and all that. You throw these on for search and rescue. On a side note with like Meshtastic, like that's you want to get really nerdy on it, look up a software called ATAP, which it used to be called the Android Team Assault Kit because it was made by the US Army. Now they call it the Team Awareness Kit, so it's more politically friendly and but it's really cool Android software. Basically, it's got a map and it was developed by the US Army for small teams to actually communicate information between each other. Because with the military, like, you know, the sizes of things, like at the brigade level, there's like computer systems to do command and control and see where all your assets are moving and all that kind of stuff. And when you think about radios, right, like the individual soldier doesn't have a radio to talk to an individual soldier 70 kilometers away, right? Because, you know, imagine 200 amateur radio operators all trying to run a net during a marathon. It gets busy really quick, right? So long story short, so that made it really difficult. So it wasn't a ton of radios. So now what they do is they have Android phones on their vest and they can see like where all their other soldiers are, and they can draw on the map and it syncs to all the other soldiers, and they use military radios and all communicates. They open sourced it, and so now like search and rescue teams and stuff are using it because they can map out, okay, we searched this area, we searched that area, and they can communicate. Most of the civilian use is using the LTE cellular modem in the phone itself to be able to synchronize the map and send messages and stuff like that. Well, if you do ground search and rescue in northern Manitoba and there's no cell phone connection, how do you synchronize your map to say I've searched this area or send a text message to another 2-person team somewhere else? So they've been using Meshtastic to be able to, and there's plugins that it exists to be able to synchronize all that telemetry. So now they can text each other and all that kind of stuff. No cell phones, no satellite, no Starlink, nothing. So that stuff's really cool if you end up Googling that. Just know that if you start playing in Meshtastic, you will end up on Prepper TikTok, Prepper YouTube at some point. So, and Second Amendment and all that other stuff. So, but there is some good info out there, and there is some cool uses, even from a friendlier perspective.
From an IoT point of view, can you send commands through it to control an IoT device somewhere within your 10-kilometer range?
Yes.
Yeah.
Meshtastic has that kind of built into it.
Like it can just, you can like by API, you can send it custom.
Yeah, you just punch in a code and then it sends it and it receives it and it initiates.
So that's kind of the original intent of LoRa WAN.
Yeah.
So more purpose built.
Yeah, because LoRa WAN is just the library that they build their systems on, right? So it's kind of like the way I think about it is it's like think about like IP packets. You can put whatever you want in the message, right? So whether it's actually, or maybe I'm explaining it wrong, but like instead of being IP, it can be whatever you want in that like Ethernet frame, right? We just typically will encapsulate IP. So it's the same idea here where, yeah, it can be an English readable text message, but it could also just be a randomly encoded short message, right? So as an example, if we're doing telemetry at a repeater site that had batteries, right? And we needed to report voltage every hour, I wouldn't send a message that says voltage equals 13.7. I would just have like 13.7 / something something, and I would just know what my format is to parse it.
And up to 50 kilobit bandwidth, is that what you said?
50 to 50 kilobits is the theoretical max.
Kilobits.
Yeah, like you would have to have the lowest spread factor, maximum bandwidth, etc. So like the default setting, for example, is 62.5 kilohertz bandwidth. It can go up to, so Meshtastic or MeshCore can go up to, I believe, 500. But then there's some regulatory things, so sometimes it's 250. 62.5 is the smallest right now. But just to give you an idea, like, right, if I go to 250, that's 4x the bandwidth. So theoretically, you could really get the bits up there. But it's no worse than 1200 baud, like HF, packed or old school. Yeah. But the other part about it too, like we talk about range because it can get into the noise floor, it also makes it very resilient to just interference in general.
About 6 kilobytes per second. Approximately.
Theoretically.
Which is pretty close to what we use for phone.
Yeah, they're probably pretty close.
All-Star.
Phone, no, phone is hundreds of,
For All-Star.
yeah. One VoIP channel is the minimum 60 kilobits per second.
60, okay.
Yes, 60,000 bits per second.
I'm sure if the like middle sim guys could figure out how to do voice chat over this, they yeah.
Any questions? Okay, thank you, Andrew. Brought snacks, eat some snacks.
I need to get one of those T-beams ordered.
Yeah, I'm gonna get the 900. What's this one I've got on APRS?
Oh, that's a 433 model?
Yeah, 433.
So does the, I think, is the LoRa chip underneath the screen then? Where is it?
Good question. Put that one there. This one. No. No,
Oh, there's nothing under the screen.
there's nothing under there. Oh, yeah, there is a chip under there.
Yeah, but I don't think that's the
No,
word chip.
probably not it.
Thank you.
No, I think that's the word chip.
This one, yeah, it says. Yeah, that is.
That thing have rubber feet on it or what?
Magnetic feet.
Magnetic, oh, that's why, okay.
One antenna here, one here.
Yeah, that's those UPS.